Hello everyone, this is Dr. Asafaro. As you remember, in the last class, we learned how can we use Proteus in basic level. Today, we want to continue with Proteus, and therefore I selected a question from our homework. And actually, I think all of you solved this problem analytically. This time, we want to solve this problem using Proteus simulation program. First of all, we are reading the question, and then how can we solve this problem analytically in classical method. The following circuit is given. Calculate I out, current out here, and V out, voltage out here. All steps of the calculation should be shown. Write the solution steps with relevant formulas in the box. When you try to solve this type of the questions, first of all, you have to pay attention about the resistors. The connection of resistors are important here. For example, R2 is connected to R4 in series because the current is coming here and going through R4 and then going through R2. You have to know this is a serial connection. If we discuss about this connection with R3, then you should say this is parallel connection because this is a series. We can calculate the total resistance value using the series formula. Just you are summing both of them, and then with R3 this is parallel. And here, for example, R5 and R6 are parallel too, because you see we have nodes and these are standing in parallel. Okay, now this is the answer for this question. The first step is to combine resistor clusters between and around the sources V1 and V2. V1 is here 10 volts and V2 has a value of 20 volts. And the branches of interest, those dealing with I out is here, and V out here. Using this series and parallel resistance formulas. Remember, we studied the formulas relevant to in series or in parallel. Resistors R2 and R4 are in series. It is clear. I already spoke about it. With an equivalent resistance of R2 plus R4. Just you are summing these two values. And this is in parallel with resistor R3. Okay, after you calculate the total resistance of these two resistors, then it is parallel to R3. Therefore, you have to remember the calculation of parallel resistors. Resistors 5 and resistor 6 are also in parallel. You see here, these are parallel. Therefore, the resultant resistance for the equivalent circuit that follows are here, R2, 3, 4 means R2, 3, 4. This is parallel, and the formula will be written in this form. You are familiar with this type of calculation. After substituting of the values of the resistors here, you will get R234 is equal to 2.0 kilo ohm. Similar things we can do for R5 and R6 because these two resistors are connected in parallel too. Since we know the resistor R5 and R6 are parallel, we can use the formula which is provided at this point. R56 is equal to R5 times R6 over R5 plus R6. After substituting of the values in the formula, you will get R56 as 2.73 kilo ohm. Here you see the equivalence circuit because it was another resistors above the circuit and on the right side of the circuit, but as you see here, we are using this time R56. It means this is the equivalent resistance of R5 and R6. And here we have resistor of R2, 3 and 4. This is the equivalence of these resistors. Now we will continue with this circuit. We want to apply Kirchhoff voltage law to this circuit. We are beginning with the left loop and for left loop we can write V1, here V1 is equal to I out here and R1. We know this formula is derived from Ohm's law. And thanks to this formula, we can find I out is equal to V1 or R1. After substituting of the values of the terms, you will get 10 milliampere. It means I out at this point is equal to 10 milliamperes. Applying Kirchhoff voltage law to the right loop tells us that the total voltage across R23 and R56 in the assumed direction of I234 is equal to V1 minus V2. It means the voltage drop at this point is equal to V1 minus V2. Voltage division equation we studied can then be used to determine the voltage drop across R234 in the assumed direction of I234. Assumed direction means here we think the current is flowing from right to left. This is assumption. Later, if we find negative value of it, it means our direction is not correct. Just we are changing our direction to the right. Because V1 is referenced to ground, you see here V1 and this is ground. The voltage on the left side of resistor R234 is V1, and because the voltage drops by V234 across the resistor, we desired output voltage is V out should be equal to V1 minus V234. After substituting the values, you will get V out as 14.2 volts. Please note that because V234 was found to be negative, the actual flow of current through R234 would be in the opposite direction from that assumed in this solution. A myriad of methods may be used to solve this problem, and the one presented here is just an example solution, not necessarily the best method. Every time when we are asking questions, there are some ways to solve the problems. Therefore, it is up to you which method you want to use for solving of the question. Until now, I solved question 9 of the homework using classical methods. It means how can we solve using analytical way to find the result. Now I want to show you how can we use Proteus and how can we design these circuits on simulation program and see the values what we found here. And now I want to upload Proteus software to show the circuit there. Let me upload Proteus now. I downloaded earlier and now I am waiting the Proteus software simulation software program to be uploaded. We are waiting a little bit. Okay, now this is our main page. Maybe your version is latest. This is 8.15 that I am using now. And now, first of all, you have to select new project. Come on. Okay. Here, project name, it is up to you. But as I earlier said, it is not available for us to save this software because we are using demo version. There are limitations when you are using the demo versions. Therefore, it is up to you which kind of name you are providing for your project because you could not save it. Therefore, I don't waste my time. Just I select next button here. And default, create a schematic from the selected template. Then do not create a PCB layout. I told you PCB layout means if you want to create this circuit, what you created on a card, then you need this selection. But I will not create a card, therefore I am selecting do not create a PCB layout. Next. No firmware project. Next. And finish. Okay, this is our layout. We will work with our circuits on this page. I want to see my question here. Therefore, I need smaller window, and this is the question. So the problem was that this is our circuit. Please remember, first of all, you have to bring the parts what you want to use. And here we have 6 resistors. Therefore, I am clicking on the part list here. And on the new window, I am typing here resistor. Okay, this is the figure of resistor. This is correct one. I am selecting it. Okay, we have resistor here. And then we need batteries here. Two batteries. You see V1 and V2. The values of the batteries for V1 is equal to 10 volt, while V2 is equal to 20 volts. And therefore, I am coming back and I am selecting cell. Okay, this is cell. It means battery. And now I am selecting our battery. First of all, we can begin with the left side of the figure, and we will select resistors, 6 resistors totally. Okay, resistor, and just I am clicking here. Okay, this is one resistor. Then second one, third one. Just I am clicking, you know. Five, and this is 6. Okay, resistors are here. As you see in the figure, we need resistor vertically. Here vertical, vertical, vertical. R5 and R6 vertical 2. Only R3 is located horizontally. We are trying to change the position of the resistors. I am coming to on it, selecting the resistor first, and right click and rotate anti-clockwise. Okay. According to our figure, except R3, all of them should be in vertical direction. Selecting, right click, rotate anti-clockwise. For R4, we are doing the same things. R5, rotate anti-clockwise, and R6. Now I want to create my circuit. I am taking this here, and then this is the vertical line, what you are seeing here, and then here. And we have here battery. Okay, this is, you have to click twice. Okay, here, and escape. You remove, if it is dragging, then you can press the escape key. This is R1, and here going to right. Okay, then I can bring my cell here. This is cell. And complete the connections. And here we have, okay, this is, now where is R2? R2, select R2 and bring R2 here. Repeat, do not leave the left button of mouse, and I have to bring here according to my figure here, and then connection should be completed here. R2, and then this is the upper side of the circuit, and so, and here I need R4. There is R4. R4, and then R3 should be here. You can change the position of the window using this corner here, and now it should be connected here. Oh, but I didn't bring R3 correctly. Okay, where is our R3? Later we can type on it. First of all, I want to continue with my drawing. Here, okay. And then we have here another cell at this point. There is cell is here. Change the position, rotate it clockwise. No, it should be underside, because as you see here, positive side is here. Therefore, I am rotating again. Right click, rotate 180 degrees. Now it's correct. There is battery. Okay, we have here another resistor. And the value of the resistor is given there, 5 kilo ohm. I have to bring it to here. Double click, and where is the resistor? This is the resistor 5, I think, yeah. Every time then I am dragging, then a part is coming, not all of them. You can create here resistor 5 directly here. It's possible to if you have difficulties. It should be R5. I am changing the name R5. Connecting to here. You see here part reference, it was R3 and type R3. What is the value of it? It should be 3 kilo ohm. Therefore, I am typing here 3 kilo ohm. Okay. And I want to change this resistor. Okay. Here resistor. Here and change the name. Yes, R3 is correct. R3. And the value of it 3. We will change all of them. But first of all, I want to complete my circuit. You know, my screen is small and therefore I cannot see clearly. If you work on a big screen, then it is more availability for you to read correctly. Okay, first of all, I want to change our values. It should be R1 as a value of 1 kilo ohm. Here I am changing 1 kilo ohm. Just I am clicking on it, double click, and then I am changing. Battery value is 10 volt, 10 volts. Here 10 volts. And then R2 value is 2 kilo ohm. Come here, double click, and change the value to 2. Okay. We already did R3. What about R4? R4 4 should be 4. 4 kilo ohm. And R5 is given as 5 kilo ohm. And the battery, second battery, has a value of 20. Volt. Our circuit is not completed because there is another resistor with the name of R6 and the value of it is 6 kilo ohm. We have to add this resistor to our circuit. Okay, this is resistor 6. Now the connection for resistor 6, and then we have to connect and changing the resistor value. This is 6 kilo ohm. I think we completed our circuit. I want to check one more. 2, 4. Yes, now I can enlarge our figure. Okay, here. So we have to add a ground to here, because you see here we have a ground here. Come here and check the ground here and make here. Okay, this is our ground. The connection is needed. This is our connection. Okay, we added ground, and you can find the ground item under this terminus mode. Okay, now I am checking again. I think it is completed. Now I want to measure at some points. First of all, we want to see, for example, minus 4.23 volt. It should be at V234. V234. Okay, it means we want to measure voltage here. You see here V23. And for doing that, I need an instrument. And this instrument is called, first of all, we have to come here and find our instrument item. This is instrument. And I need a DC voltmeter. This is DC voltmeter. Now I can bring this voltmeter here. First of all, I am putting here. This is my voltmeter. I told you voltmeter cannot be used vertically. I tried to use vertically, but I could not succeed. Therefore, I am changing the position, rotating it anti-clockwise, and now I am connecting to the V out. V out is here. Okay, here, connection. And then here. Okay, here. I connected a DC voltmeter between these nodes, here and here. I want to run my simulation. For doing that, you are coming to left side, bottom, and you see there is an arrow directed to the right side, and click on it. Okay, here there is a voltage minus 5.24. I have to check my voltmeter again, because the value is 5.24. Something is not exactly. First of all, I want to check all my batteries values: 10, 20, 6 kilo ohm, 5 kilo ohm, 4, 3, 2, 1. Yes, this is correct. You can change the poles of the voltmeter to see. For example, if you bring to here or bring another position, then you will get a different result. Again, here our solution: 2, 3. I want to connect here to once and see what happened. You can change the position. You can try and see what happened if you change the position of voltmeter. Now click on it, right click, and delete wire. This time I want to connect here, and this is an availability for you to check your system. For example, now you will see the voltage here, and run the simulation program. Okay, this is still 5.24, and we continue to changing of the position of the voltmeter. You can change the poles of voltmeters to measure different parts of the circuit. For example, if you connect this line here to here, then running the simulation, you are getting 5.24. And if you want to measure the current on this line, for example, you need a DC ammeter. I want to bring an ammeter here. Here, this is. Okay, here. This is ammeter. Ammeter should be connected directly to the line, online. I have to enlarge it. We are selecting AC ammeter here, and click anywhere. You can drag it later. Okay, this is our ammeter, and bring to here. Click on it. Okay, we connect it. Now I want to run up my program and see what is the value of it now here. You see here 0.01, but the unit of it is ampere. I want to check with my result here. It should be 10 milliampere. 0.01 ampere is equal to 10 milliampere, or you can change on the instrument directly to. First of all, stop this simulation and come on it. Click double. Here you have to select milliampere. You see here display range amperes, and now I want to change it milliamperes. And running it again. This time you see we are reading I out as 10 milliampere. This is correct with our solution. But here we have 5.24, but in the solution we found 4.23. This is an assignment for you. Why do we get different result here? 4 minus 4.23, but we found here 5 minus 5.24. You see here. And where is our ammeter? Ammeter is 10 milliampere. Okay, this is the second example about usage of the Proteus. We will continue solve our circuits using Proteus in future. I suggest you to try this type of circuits on Proteus yourself. Later in the class, I will explain the menus. There are many menus here and here. We will learn the role of them. For example, what is generator mode? You see, sine. This is the type of the signal, DC, etc. And then we have here instruments, different types of the instruments, wattmeter, ammeter, voltmeter, etc. DC or AC. Oscilloscope we have. We can use oscilloscope directly here too. Oscilloscope is an instrument that can be used for finding of the character of signals and other values. The oscilloscope. You see this type of, you can put any oscilloscope in your figure too. But every time we have to stop our simulation, otherwise you cannot go further. This is the availability of the software. Without stopping of the simulation, you cannot change anything on your circuit. Okay, we will learn oscilloscope, logic analyzer, etc. later, and then there are some additional menus here too. We will try to learn them too. Now I think this is enough for this week too, and please listen carefully what I did here, watch again and again, and be ready to use Proteus efficiently. If you have questions, please do not hesitate to send email to me and ask your questions. Okay, these are our instruments, so I can see on the screen, enlarged, and simulation, run the simulation, and we are reading the values here. So thank you very much for listening to me, and see you in next class. Bye.